Rahim. Assalamu alaikum, dear students. Today, this is lecture number 3 for numerical analysis. In the last chapter, we have studied Newton forward difference interpolation formula, and in this lecture, we'll try to cover all the rest of the methods for calculating the approximate value of a function. So let us start. The second formula is Newton's backward difference interpolation formula. The idea of this method is the same as given in the previous one, that you will be given a set of data like x0, f0, x1, f1, and so on. You can write this data in the form of a table that I told you before. Secondly, we need to construct a difference table and identify f0, nebula f0, nebula square f0, nebula cube f0, and so on. In Newton's forward difference formula, we have calculated f0, delta f0, delta square f0, but in here, in this formula, we will calculate nebulas for f0. And the same as the previous manner, that we need to calculate HP, where XP will be given to you people. And the last one is, when all this process is completed, then we will be able to apply Newton's backward difference formula to calculate f of xp, and the formula for Newton's backward difference interpolation is this one. You see that in this formula, instead of deltas, there are nebulas. This is nebula f of naught. If you see here, nebula f of naught, nebula square f of naught, nebula cube f of naught, nebula 4 f of naught, and so on. Secondly, instead of negative sign, here is plus sign. You see, in Newton forward difference formula, this sign was negative. All these signs were negative in Newton forward difference formula, but in backward formula, that is plus. So there are two differences in Newton forward and backward formula, that these signs are opposite to each other, and secondly, deltas and nebulas are there. So we need to apply this formula. Let us start to understand this formula with the help of an example. The question is, use Newton's backward difference formula to compute f of 11.8 from the data given below. The data is given in the form of a table. The values of x are there, the values of f of x are there. So let us start to make a difference table for these values of x and f of x. That is a table. Difference table will be prepared in the same manner as we have discussed for in Newton forward difference formula, that second minus first is this one, third minus second is this one, fourth minus third is this one, and so on and so on. So because nebulas are used in Newton's backward formula, so instead of deltas, we have written here nebulas. And next is, we need to identify the value of x0 and f of f0 along with its differences. If you see here that we need to find f of 11.8, so 11.8 is actually xp. 11.8 is xp, so this is xp. we search here that whether 11.8 lies between here, there, or there. We see that 11.8 lies between 10 and 12. Between 10 and 12, 11.8 lies. So upstairs is x0 and downstairs is x1, and that is xp. In front of this x0, this is f0. So for nebula, for delta, you already know about from the previous example that if this is f0, then for delta we will go from upstairs towards downstairs. But for nebula, we will go from downstairs to upstairs. This, if this is f0, then the above value is nebula f0. This above value is nebula square f0. That is nebula cube f0. That is nebula 4 f0. So all those nebulas have been calculated. x0 is there, xp is here. So let us find x0. Let us find xp is given, x0 is there, x1 from table is 12. So we are in position to calculate h, which is x1 minus x0, and also in position to calculate p, which is in front of you. That is the same as for Newton forward difference formula. So we are in position to apply Newton's backward difference interpolation formula, which is this formula, because in the table, if you look at the table, in table we have found 4 differences, but the 4th difference is 0. The last 4 difference column is 0. So we extend the formula up to 3rd difference, that is nebula cube f0. So we need to put all those values here. Instead of xp, we have written here 11.8. Instead of f0 from table, this is 1071. P is 0.9. This is p. Nebula f0 is 502. P is 0.9. P is 0.9. Nebula square f0 is 192 from table. P is 0.9. Then 0.9 plus 1 plus 2 divided by 3 factorial is 6, and nebula cube f0 from table is 48. So whenever you calculate this sum, you will get this answer 1727. So this is the answer for this question. The main difference, there is nothing else which is different from Newton forward difference formula from here up to there. The difference is the difference of the formula. So for Newton's backward difference interpolation, you need to write this formula, and for forward difference interpolation, you must remember that formula. So I hope this will help you a lot. So now we are in position to start Stirling's interpolation formula. Stirling interpolation formula, this step is the same as discussed previously, that the data will be given to you. Secondly, we need to construct a difference table in the same manner and identify f0, sigma f of minus 1 by 2 and sigma f of f1 by 2, because these values will be used in the formula, and other differences of these functions. The third one is we need to calculate HP, where XP will be given. That is the same step as discussed before. And the last one is we need to use Stirling's interpolation formula to calculate f of XP. So Stirling's formula is this one. That is Stirling's formula. That is f naught, then half of p, and sigma f of f minus 1 by 2 plus sigma f1 by 2 plus 1 by 2 factorial p square sigma square f naught, sigma square f naught plus p into p square minus 1 2 into 3 factorial. That is the first difference of f minus 1 by 2 and f1 by 2, and this one is the third difference of f minus 1 by 2 and 1 by 2. That is the second difference. The differences goes in the same manner. That is the first difference, second difference, third difference, and then p, that is p. So one p will be increased, so that will be p square. P square minus 1 is the same, and this is 4 factorial. You see here that is 1 by 2 factorial along with sigma square f naught. So this is sigma 4. After sigma cube there is sigma 4 f naught. Then p into p square minus 1, p square minus 2 square. This is that is actually 2 square. 2 square is 4 divided by 2 is here, so 2 is there, and that is a 4 factorial, so this is 5 factorial, and that is the fourth difference, so that is the fifth difference in the same manner. Fifth difference in the same manner. And then that p will become p square into p square minus 1, p square minus 4 divided by, after 5 factorial there is 6 factorial, and then that is the fifth difference, so that is the sixth difference, and so on. So this is Stirling's interpolation formula, and that is the main thing to remember the formula. You need to remember the formula by writing this formula 4-5 times on a page, so you will be able to remember this formula. Now the structure for Stirling's interpolation formula, that how could we know that what is f naught and what is f minus 1 by 2, what is f1 by 2. So the structure of this formula is just like this one. Whenever you identify x naught and x1, so definitely above x naught there is x minus 1. When you go upstairs, that decreases. When you come downstairs, that is increased. 0 1, then 0 minus 1. So in the same manner, that is x naught, so this is f naught. Above this is f minus 1, and that is f1. So if this is f naught, between f minus 1 and f naught, here is sigma of f minus 1 by 2, half of these two, half, and here is 0 and 1, here is half of f, that is the first difference of f1 by 2. Then in front of this f naught, in this third column, there is the second difference, that is the second difference of f naught, sigma square f naught. Then again, that is sigma cube f minus 1 by 2 and sigma cube f1 by 2. Then again, that is the third difference, so this is fourth difference of f of naught, and that is the fifth difference of f minus 1 by 2 and f1 by 2, and so on. So from table you will you will be able to recognize f naught and f minus 1 by 2, 1 by 2, and their differences in this manner. Let us start an example to understand this formula. The question is, use Stirling's interpolation formula to find f of 1.62 from the following table. The table is given to you. We see that 1.62 is nowhere here, and 1.62 lies between 1.6 and 1.8. So this is interpolation. We'll find f of 1.62 with the help of Stirling's interpolation formula. So let us start. First of all, we need to construct a difference table in the same manner, and because sigmas are there, so instead of delta and nebula, we'll write sigma for differences. That is, the first difference will be denoted by sigma, second difference will be denoted by sigma square, then sigma cube, then sigma 4, and the criteria is the same, that second minus first is this thing, third minus second is this thing, fourth minus third is this thing, and fifth minus fourth is this thing. We see that we have ignored point in this table. You can put point over here. That is, after this decimal point there are 4 digits. So remember that after this decimal there are 4 digits. So there are when you subtract these two, you'll get this answer, and this answer contains 5 digits, 79576. 795. In this table we see that this decimal point, after this decimal point there are 5 digits. We can put 0 over here to make 5 digits after this decimal point, because all the numbers are in this form. So here there are also 5 digits, so there is a point, but we have ignored this point for the purpose of for our convenience. Here there are 5 digits, and this in this column we see that all the numbers have 5 digits. So before these 5 digits there is a point, but we have ignored this point for the purpose of convenience. Thirdly, if you come here, when you subtract these two values, I mean second minus first, you will get a negative sign, but there are 4 digits. We see that there are 5 digits, so it means that we should put a point before 5 digits, but these are 4 digits, so you must put here a 0, then point here. So this minus 6438 is actually minus 0.06438, 0.06438. Similarly here this is minus 0.07167, and this is 0.07827. Come towards the third difference. When you subtract these two, this minus that, you will get this answer, but the original numbers are there are 5 digits before after this decimal point. So but these are 3 digits, so we must put here 2 zeros, then a point. So this is 0.00729 and this is 0.00660. In the same manner, this is actually 69, but we must write 5 digits after the decimal, so put 3 zeros over here. So this is actually 0.00069. We have ignored all those zeros along with this decimal sign for the purpose of convenience. You can write those zeros in the table, there is nothing else, but I think this point is will be clear to you people. So in the same manner, we need to identify f0 and f minus 1 by 2 and f 1 by 2. 1.62 lies between 1.6 and 1.8, so x0 is 1.6 and x1 is 1.8. In front of this x0, this is f0. According to the structure of Stirling's formula, we will go in this manner. This is sigma f of minus 1 by 2, and this is sigma f of 1 by 2. Again, this is sigma square, that is the second difference. This is sigma square of f0, this one, and again that is sigma cube of f of minus 1 by 2 in front of this f minus 1 by 2, and that is sigma cube f1 by 2, and the last value is fourth difference of f0. So this structure, remember this structure for Stirling's formula. Let us apply the formula. xp is 1.62, for which f of xp is to be determined. x0 from table is 1.6, x1 is 1.8. Now we are in position to find h in this manner, and now in position to find p in this manner, and now we are in position to use Stirling's interpolation formula, which is this formula. So from table we need to replace all those values. I mean, instead of f0, this is f0, p is 0.1. you see, this is p 0.1, and sigma f of 1 f minus 1 by 2 is from table this one, sigma f1 by 2 is this one, p square, this is p square, 0.1 into 0.1, or sigma square f0 is minus 0.7167. thirdly, sigma cube is this one, sigma cube of f minus 1 by 2 is this one, and this is p into p square minus 1, so p into p square minus 1 divided by 3 factorial is 6, 6 into 2 is 12, and this is p square, so p square means 0.1 into 0.1, and p square minus 1 is this one, 4 factorial is 24, and sigma for f0 from table is 0.00069. After calculating this sum, we will get the answer which is in front of you people. So this is the criteria for Stirling's interpolation formula. We see that in all these questions there is nothing else which is new in these three steps. These three steps are the same. The main difference is the use of the formula, so the formula must be remembered by you people. Now come towards Bissells interpolation formula. Set of data will be given to you people. We need to construct a difference table in the previous manner, and will identify f0, f1 by 2 and f1, because these values will be used in the formula and their differences. And the third step is the same. We need to calculate hp, xp will be given, and the fourth step is of course the use of the Bissells interpolation formula, which will be different from the previous formulas, and that is in front of you. So fp is actually f of xp is f0 p into sigma f1 by 2 plus p into p minus 1 divided by 2 into 2 factorial sigma square f0 plus sigma square f1 plus p into p minus 1 into p minus 1 by 2 divided by 3 factorial sigma cube f1 by 2 plus p plus 1 into p into p minus 1 p minus 2 2 into 4 factorial sigma 4 f0 plus sigma 4 f1. That is the formula which is called Bissells interpolation formula. Let us solve the structure. The structure of Bissells formula is this one. Whenever you identify x0 and x1, so in front of x0 there is f0, and in front of x1 there is f1. So whenever you identify f0 and f1, then between 0 and 1 there is 1 by 2. So between f0 and f1 there is f1 by 2, and that will be the first difference of f1 by 2. Then that is sigma square f0, and this is sigma square f1. Again, that is sigma cube f1 by 2, and that is sigma 4 f0 and sigma 4 f1, and so on. So remember the structure of Bissells interpolation formula. Let us try to solve an example. We are given a table of values, and the question is we need to construct a difference table, and including differences up to 4th order only. So we need to make a difference table up to 4th difference. And the second part is we need to interpolate f of 3.64 by the use of Bissells interpolation formula. So the answer is, first of all, we need to construct a difference table. That is a difference table, and the difference table will be constructed up to 4th order only. After decimal point there are 6 digits. So before 6 digits we need to put this decimal sign, this point sign. So the first difference contains 5 digits, so we need to put 0 here, then point. These are 5 digits, so we need to put 0 here, then point there, and so on. So these are 4 digits, so we need to put 2 zeros before 2, then a decimal sign. Put 2 zeros here, then a decimal sign, and so on. These are 3 digits, so put 3 zeros before 3, then a decimal sign. Put 3 zeros, then point, 3 zeros, then point, and so on. These are 2 digits, so we need to put 4 zeros before 1, then a decimal sign, and so on. So that is a difference table. Secondly, we need to identify f0 and f1. We need to calculate f 3.64. So f of 3.64 lies between 3.4 and 3.8. So the above value is of x0, and in front of x0 there is f0. This is the value of x1, so that is f1. Between f0 and f1 there is f1 by 2. So this value is actually f1 by 2, but first difference of f1 by 2. Expanding this value up to 2 values in the next column, so that is sigma square of f0, and this is sigma square f1. Then descending it up to 1 value, that is sigma cube of f1 by 2, and that is sigma 4 of f0 and sigma 4 of f1. So in this manner, following the structure of Bissells interpolation formula, we are in position to solve this question. xp is given, x0, x1 are being identified, h has been obtained, p is calculated, and the last one is we need to use Bissells interpolation formula, which is this one. So replacing the values of f0, p, and sigma f1 by 2 and all those values to calculate f of 3.64. So this is the value of f of 3.64. Now the coming formula is Everett's interpolation formula. In the same manner, a set of data will be given to you people. You need to construct a difference table and identify f0, f1 by 2, f1, because these values will be used in the formula and their references as well. Calculate hp, where xp will be given, and the new thing is we need to use Everett's formula, which is different from the previous ones, and that is this one. we see that P is here, and along with P there is Q. So Q is actually 1 minus P. Whenever you calculate P, then Q will be calculated from 1 minus P. Structure of Bissells interpolation formula is this one. Whenever you identify F0 and F1, then the second difference of F0 will be in front of F0 in the third column, and the second difference of F1 will also be in the third column, and in the fifth column there will be the fourth difference of F0. So you need to go in a straight line to find these even differences. This is an example. Table is given. You need to construct a difference table up to 4 differences and interpolate f of 3.64 by using Everett's formula. So the difference table is this one, as we have constructed this table in the previous question. That is the difference table. And secondly, we need to identify F0, F1. So in front of F0 in the third column, this is the second difference of F0, and this is the fourth difference of F0. That is in front of F1, that is the second difference of F1. That is the fourth difference of F1, not F0. So this is F1, not F0. XP, X0, X1, that is an old story. H is the old story. P is the old story. And this is the new story, that Q is 1 minus P. You have calculated P as 0.6. So Q is 1 minus P, 1 minus this P. So 1 minus 0.6 is 0.4. So Q is 0.4. Now other new story is we need to use Everett's interpolation formula, which is this one. We have extended this formula up to 4 difference because the table consists of 4 differences. Putting all those values from the table, Q and P, F0, F1, their differences, whenever you put all those values, you'll get the answer with the help of a calculator. So that is Everett's interpolation formula. Remember that the formula is important to remember. Write a formula 4, 5, 6 times to remember that in your mind. Next one is Gauss forward interpolation formula. That is an old story. This is again old story. We need to construct difference table and identify F0 and F1 by 2 because these two will be used in Gauss forward interpolation formula. Calculate HP, XP, the same one, and the new one is we need to use Gauss forward interpolation formula in this manner. This is Gauss forward interpolation formula. F0 plus P into sigma F1 by 2, P into P minus 1 by 2 factorial sigma square F0, and P into P plus 1 P minus 1 by 3 factorial sigma cube F1 by 2, P plus 1 P minus 1 P minus 2 divided by 4 factorial sigma for F0. Structure of Gauss forward interpolation formula is this one. Whenever you identify F0 and F1, so between F0 and F1 there is F1 by 2, but that is the first difference of F1 by 2. That is the second difference of F0. This is the third difference of F1 by 2. That is the fourth difference of F0, and this is the fifth difference of F1 by 2. Example is there, table is here. We need to construct a difference table up to 4 order and use Gauss forward interpolation formula to calculate F3.64. So difference table is the same as previous. Now just look at this thing. Identify F0, that is F0 in front of X0, that is F1. Between F1 and F0 there is F1 by 2, but this is the first difference of F1 by 2, and this one is sigma square of F0. This one is sigma cube F1 by 2, and that one is sigma 4 F0. Old story, XP, X0, X1, H the old story, P the old story, And this is the new story, that using Gauss forward interpolation formula up to 4 differences and replacing all those values to get f of xp, which is in front of you. We have studied Gauss forward interpolation formula. Now this is Gauss backward interpolation formula. Set of data will be given to you people, difference table will be constructed, and instead of f1 by 2 and Gauss backward formula will recognize f minus 1 by 2 and their differences. So that is the major difference between backward and forward Gauss formulas. That is the whole story, that we need to calculate HP where xp is given, and Gauss forward this is actually Gauss backward interpolation formula is this one. You see, instead of 1 by 2 there is minus 1 by 2. So this is minus 1 by 2. Signs are changed. There were negative signs, now there are positive signs. So that is the Gauss backward interpolation formula. The structure is just like this. Whenever you identify f naught, so above f naught there is f minus 1, between f minus 1 and f naught there is f minus 1 by 2, and that is the first difference of f minus 1 by 2. Then below is the second difference of f naught, above is third difference of f minus 1 by 2, below is the fourth difference of f naught, above is the fifth difference of f minus 1 by 2, and so on and so on. That is the same question. We need to construct a difference table and interpolate f of 3.64 by Gauss backward interpolation formula. So the difference table is the same as before. Just look at that. In front of f naught, in front of x naught there is f naught, and that is f minus 1. That is f minus 1. Between f naught and f minus 1 there is f minus 1 by 2. This is actually minus 1 by 2. So this is minus 1 by 2. That is actually minus 1 by 2. So that is the structure. Remember that xp is given, x naught and x1 are from table. Calculate h, calculate p, and use Gauss backward formula, which is this one, and putting all those values from table to get the answer of this question. So this is the end of interpolation formulas. When you are given equally distinct arguments, that the difference between the values of x is the same. In other words, h is the same. This is the last topic of this chapter, that whenever you are given unequally spaced arguments, it means that the gap between the values of x is not the same but different. So interpolation for unequally spaced arguments, we use Lagrange's formula. Lagrange's formula, set of data x naught up to xn will be given, that may or may not be equidistant. May be or may not be equidistant, but as a special case, may not be equidistant. Find first an nth degree polynomial will be obtained. We will discuss in this example by using Lagrange formula, which is as under. That is the function f of x. So the function f of x, if you look at here, this is f of x naught, this is f of x1, this is f of x2, and so on. This is f of x on. So all those functional value, whenever there is x naught, so from x naught the rest of the values of x will be subtracted. From x naught all those values will be subtracted. X naught minus x1, x naught minus x2, and so on, x naught minus xn. Look at this numerator. There is no sign of x naught. X naught is missing upstairs. and we just need to write x minus x1. We will start from x1, x minus x1, x minus x2, and so on, x minus xn. X naught will be missing in numerator here. And the second step, plus, that is f of x1. So from x1, the rest of the values of x will be subtracted, x1 minus x0, x1 minus x2, and so on, x1 minus xn. This is denominator. And in this term, x1 will be missing in numerator. You see, x1 is missing. X minus x0, then x minus x2, not x1. So x minus x2, x minus x3, and so on, x minus xn. Similarly, in the third step, this is f of x2. So from x2, rest of the values of x will be subtracted, and x2 will be missing upstairs, and so on. This is xn. So from xn, rest of the values of x will be subtracted, and in numerator, xn will be missing. So this is actually Lagrange formula. So first of all, we will use this formula to obtain a nth degree polynomial, and whenever you obtain a polynomial, we will evaluate this formula for a given value of x. Look at this example. The question is, fit a polynomial using Lagrange's formula to the following data. This is the data: 1, 4, 3, 7, 4, 8, 6, 11. This is x0, this is f0, x1, f1, x2, f3, x2, f2, x3, f3. Secondly, whenever you find this polynomial, then use this polynomial to estimate the value for x equal to 5. Writing the ordered pair in table form as this one. We have written these ordered pairs in the form of a table. This is x0, and this is f of x0. So x0 and f of x0, x1 f of x1, x2 f of x2, x3 f of x3, and so on. So because this table is extended up to x3, so we will use Lagrange formula up to x3, f of x0, and in denominator you see here, rest of the values of x, x1, x2, x3 are subtracted from x0, and x0 is missing in numerator, plus, that is the second term, and that is f of x1. So from x1, rest of the values of x are subtracted, and x1 is missing in numerator, that is x2. So in denominator, rest of the values are subtracted from x2, and x2 is missing in numerator, and the same criteria is followed in this last term. There is no x4, so we have extended Lagrange formula up to x3. You just need to put the values of x1, x2, x3, x0 from here, and the values of f of x0, f of x1, f of x3, f of x2 from there, and calculate the answer. Putting the values, we will get f of x in this manner. Simplifying, multiplying these brackets, you will get this thing. From here you will get this term, that is this term, and this is that term, and simplifying these four terms, we will get this answer. This is f of x. Now the second thing is, we need to calculate this is f of x for x equal to 5. So you just need to put x equal to 5 and the last step along with this f of x. Replace x by 5, x by 5, x by 5, x by 5 to get this answer 9. So that is the end of this chapter, and we have studied these formulas. I hope that you people will enjoying listening this lecture. If there is any difficulty, any problem, any question, then do remind me, do contact me, in order to solve that problem. Allah Hafiz.